Hello, thank you for checking out A1 Math, and today we're looking at the recursive formula for an arithmetic sequence. And what we want to do is take a sequence, determine if it's an arithmetic sequence or not, then plug in the first term and the common difference into this formula. And this is the recursive formula. So with the recursive formula, what you have to do is state the first term and write in your common difference into this formula. So let me show you an example. So in this problem, number 7 here, we're given a sequence. And what we want to do first is determine if it's an arithmetic sequence or not. So in order to do that, you have to have a common difference between here to here to here. So the simplest way to do that is to take your second term and subtract it for your first term. So I have 103 minus 3. And that's going to give me 100. All right. Now, to make sure it's an arithmetic sequence, I could go ahead and take the third term and subtract it from the second term. So that'd be 203 minus 103, which is still 100. So now we have a common difference. Okay. So now we've determined that it's an arithmetic sequence, and that's it. All you have to do now from here on out is fill in what your first term is. So a of 1 will be the first term, which is 3. And then write this formula with everything staying the same, except on the end, this should be plus your D, which is your common difference. Okay, and it's n minus 1 here. That just means it is your previous term. So to find whatever term you're looking for, you'll add 100 to it. So to find the fourth term, you need the third term. So 4 minus 1 is 3. And what is ace of 3? Well, ace of 3 is 303. And you would add 100 to it and get you 403. You always need the previous term in a recursive formula. But this is the answer here as far as writing the formula. Let's take a look at another example. So we're going to take the second term and subtract it from the first term. Negative 22 minus negative 12. And here we have two negatives that become positive. So we're doing negative 22 plus 12. So negative 22 plus 12 is negative 10. All right, now I'm going to take the third term and subtract it from the second term and see what I get. So I got negative 32 minus negative 22. Okay, two negatives become a positive again. And that's going to leave me with a negative 10. So now we have a common difference. All right. So now that we have the common difference, all we got to do is write the formula. So remember, you always got to list the first term. So the first term here is negative 12. And now I'm going to write the recursive rule and just replace the common difference with my common difference here, which is don't know why I put 12, but it is 10. So this, the first term is 12. I'm sorry. First term is 12. And then you got a sub n is equal to a sub n minus 1 minus 10. So this is the answer here. All right, so take a look at these next problems here, 9 and 10, and see if you can write the recursive formula. All right, let's take a look at number 9. So remember, we've got the thing we need to find is our first term, a sub 1. What does that equal? And then we're going to plug it into this formula. A sub n is equal to a sub n minus 1 plus the common difference. So as you can tell, all of these are arithmetic sequence, but I'm going to test to make sure that they are. So I'll take the second term and subtract it from the first term. 36 minus 32. And that's going to give me 4. And then I'm going to take the third term and subtract it from the second term. So now I've got 40 minus 36, and that also equals 4. So now I'm set. All I got to do now is write the first term, which is a sub 1 is equal to 32, and then write in my common difference here. A sub n is equal to a sub n minus 1 plus 4. And since I'm adding 4 to each term, to get the next 3 terms, all you have to do is add 4 to 44, which will get you 48. And then add 4 to 48, and that's going to get you 52. And then add 4 to 52, and that'll get you 56. So that's the next 3 terms. But this is writing it in the recursive rule, the recursive formula there. All right, let's take a look at number 10. All right, so on number 10, first thing we want to do is make sure that it is an arithmetic sequence. We're going to take the second term and subtract it from the first term. So you have 167 minus a negative 33. Okay, 2 negatives will make a positive here. So we're doing 167 plus 33, which is equal to 200. All right, now we're going to take the third term and subtract it from the second term. So you got 367 plus, subtract 167. Now you get 200. So you can see we have a common difference. Now we all set. All we got to do is write the first term, a sub 1 is equal to negative 33. And then write our formula. A sub n is equal to a sub n minus 1, which again, all that means is the previous term, plus the common difference, which is 200. And if I want to do the next three terms, all I have to do is add 200 to the one before. And that'll get me 756. $9.56 and $11.56. But this is my recursive rule right here. And that's it in a nutshell. Okay. Okay, here's a couple, or I say a couple, but here's a few practice problems. Here, I need you to write out the explicit rule and the recursive rule, and then tell me whatever term you're looking for, and like your number level looking for the 29th term. So this is kind of like practice for the recursive and explicit rule here. But that's pretty much it for right now. Thank you for checking out A1 Math. Have a nice day.